have enough information for that. We can't justify that. Awesome. Hey, one more. Data set true or false. Data set B is skewed to the right. That's true. Skewed to the right. Everyone agree? Cool. Excellent. And you got box plots down. All right, so we're going to get into scatter diagrams and correlation. I made a table over here. I want to tell you where I grabbed this table. I took it from page 191 from your textbook. So if you just wanted to know where this was in your textbook, I took this table right here. It's a table on page 191. The person who did this study was actually a student from Joliet Junior College who did this study. This involved golfers. He looked at the relation between club head speed of a golf club. So golfer, I'm a lefty everyone, but you know the golfer, and they hit the golf ball, and the speed at which that golf club is hitting that golf ball in relation to the distance that the ball traveled. And a lot of you probably thinking logically, yeah, the harder you hit the ball, in terms of distance, the longer, the further the ball should go, right? That was his idea as well. This individual's like, I'm going to look at that, and I'm going to see if there is a linear relationship. So that's what this section's all about. I know it's got scatter plots and correlation, but in section 4.1 and 4.2, 4.2 gets into linear regression. We're trying to see, is there possibly a linear relationship between these variables and these over here. So this is called bivariate data. So I'm going to put that down, that word. In chapter 4, we're turning to something new. We didn't see this before. We're looking at bivariate data. What does that mean? Oh, we got two columns, that's all. And they're these paired data. That 100 miles per hour goes with the 257 yards. That is an individual. Perhaps that's Bob, right? That's Bob. Or maybe this is Tiger Woods here. That's Phil Mickelson there, maybe, right? I know. So that's what we're talking about, bivariate data.
So is there one dependent, other one independent in this?
Excellent. That's exactly what's going on. And just like you did in an algebra class, outstanding, we consider this first column always the x,
Okay.
and then y will be dependent on x. So yeah, when you look in the book, you see two columns, you go, can I always think of that left column as the x, and the right column as the y in terms of variables? Absolutely. You know, like these are my x variables, these are my y variables. And y is always dependent on what? X. Now there's other words we use in statistics, so I'm going to write them down. This right here, this is called the explanatory variable. The explanatory variable. The explanatory variable. All right, so club head speed of the ball in miles per hour is the explanatory variable. This responds to that. Art, you said dependent, so I'm going to use, it's the response variable. This is the response variable. Yeah, that makes sense. It responds to the club speed, how far the ball goes. Yeah, okay. Hey, in some studies, I've seen people actually interchange these. Think, wait, I can make this the x and this y. Sometimes you can't. I do want to point out, it is possible to do that. All right. So the first thing we're going to do, we're going to take this data here, and we're going to make what's called a scatter diagram or a scatter plot. I bet you've heard of that before, right? We're going to plot these points. We're going to plot them all, and it's just going to look like a bunch of dots, right? Well, let's do it. Let's do it together. We'll make a scatter plot. And later on, we can use the technology to do this as well. So x-axis, y-axis. All right, here's my y-axis. There's my x-axis. We can label this. This is what? What's x? Speed. You want to put miles per hour? What's along this y-axis? The distance. Here, all right, distance. Sideways. Distance. All right. And we'll put some tick marks. We'll make some dots, right? All right, now, I don't have to start at 0, do I?
No.
What? Look in there. Check the club head speed. What's the lowest speed you see?
100.
Yeah,
99.
they call this the scope of data. And here's my scope of data. I've got from 99 to, what's the highest it got to? So as long as I make my tick marks, I can start right here at 99. I'll go by ones. 100, 101, 102, 103, 104, a little bit farther, 105. That's as far as I have to go to produce this scatter diagram or this scatter plot. Now, look at the distance. What's the lowest? 258?
That's 257.
Top one.
Ah, this is even lower. Thanks, everyone. Which one's higher? I mean, the highest.
277.
So when I'm gonna try to make this Y, I'm gonna scale it. Low is around 257, high is around 277. How about I start at a tick mark right here at 255? And then I could go by fives? Does that sound good? I'll just make each tick mark go by fives. I don't have to go by ones, right? All right, so 255, 260, 265, 270, 275. Go a little bit further up here and go 280. And that way I hit, and I can plot all these. So this is 260, 265, 270, 275. These are my distances. These are in yards. And as we do this, it's always good to do this by hand first, right? And we're like, I want to make this with the calculator or with Microsoft Excel, the spreadsheet. You absolutely can. All right. So what's the next step? We plot these. Everyone okay with plotting these ordered pairs or XY coordinates? All right, 100, 257. Doesn't have to be perfect. We'll just estimate it. For this one, I'll go over 100 up to 257. It's about here. Make a dot. 102, 264, about right there. 103, 274, about here. And this study was actually done. 101, 266, about right there. 105, 277, about there. 100, 263. Oh, so this is interesting. Two people had club speeds of 100 miles per hour. So those dots are on top of each other. This doesn't have to be like a function. Remember the function test, vertical line test in algebra? It's like, no, it's a scatter plot. Scatter diagram. This can happen. I got two more, 99, 258. It's about right there. And 105, 275. All right, that's about right there. Just estimating. Making all these dots. I try to make my dots big so everyone can see them. Does that work? Scatter plot. Scatter diagram. Boom. And we'll discuss this. We'll talk about this. Really in 4.2, we're like, man, is there a linear relation between these two variables? Between club head speed and distance. Is it linear? By linear, I'm talking a straight line, right? It's never going to be a perfectly straight line, true? Mm-hmm. But if the dots are pretty tight together, it's all going up like this. You know, we might say, hey, there appears to be a linear relation here. We can use words like strong and stuff like that. There appears to be perhaps a strong linear relation. So that's where we're going with right now. Okay? That's what we're going to do right now is talk about correlation. Everyone okay with the scatter plot? Awesome. So now let's get into that discussion. Like, how can we determine whether or not there's a linear relation possibly going on here? All right? Well, everyone, there's something called the linear correlation coefficient. And it has a math formula. I was wondering if anybody right now still has that formula sheet on them.
Yeah.
If you don't, it's okay. I'm going to put it on the board for you. I want to hold it up and you go, oh, there's a math formula for this, okay? And you go, what is it called? It's called the linear correlation coefficient. And you bet it has a formula. It's represented by letter R, lowercase r. So new symbol for us, right? We know S is sample standard deviation. X bar means sample mean. Here's R, and it represents, with bivariate data, the linear correlation coefficient.
Is that for sample or population?
This would be for a sample.
Sample, okay.
That's right. And hey, I'm talking about a sample, everyone. Over here, you see all these numbers? That's like a golfer, like Tiger Woods, Phil Mickelson, etc. So how many golfers were there? 1, 2, 3, 4, 5, 6, 7, 8. So over here, in terms of this problem right here, I just want to point out our n equals 8. Sample size does equal. I didn't want you to think you go, do I have to put 16? Because there's 2 columns. No. We're talking about a sample size of 8 with these data being paired. Over there. All right. All right, what's this formula? 1 over n minus 1. Sigma, doesn't that mean summation?
Mm-hmm.
And you got the, got to take each one of the data values, subtract the sample mean, and I'm making a product here, a multiplication. Over standard deviation of y. I'll read this to you. I mean, this is the formula. As you can see, it's pretty intense. You're like, whoa. Because we all know how long it takes just to get the standard deviation of, say, the x-axis by hand. Wouldn't that take a while? Mm-hmm. We noticed, we did it last, we're like, just to get the standard deviation of x would take a while. Then I have to get the standard deviation of y. We all know how to get an x bar, right? Mm-hmm. The mean of the x's. Remember, these are the x's. These are the y's. And what I would do is, I would sum all the products. But x sub I represents each one of those x values in there. And y sub I represents each one of those y values. So everyone, if you would like to do this by hand, it'd be, you'd be encouraged to make a table to keep this organized and do all this. But you might find yourself just doing it with a calculator. It might take you up to 15 minutes, right? Wouldn't this take a while? Mm-hmm. So is everyone okay? We're going to use technology to do this. Absolutely. More important than the tedious calculations, we understand how we put all that stuff in there and make a tables, is understanding what does this mean, interpretation. All right? So we will use technology to do this. By the way, 1 over n minus 1, in this case, that's degrees of freedom. So we're saying it's 1 over 7 because we're being golfers. So we'll find this. So I want to talk about this R value. Let's get into what does it mean. All right, so the R value, what goes on with this thing? The first thing is it only can be numbers between -1 and 1. That's the first thing I want you to know. So I'm going to write that in the board, if you understand the notation for algebra. R, the highest R can be is what?
1.
1. What's the lowest R can be?
-1.
And you, what does this R mean? Well, what's it called? It's called the linear correlation coefficient. You go, what does it tell us? It's going to tell us the strength of the linear relation in a scatter plot. It's going to tell us the strength. So what does 1.0 mean? I'm going to give you some pictures to give you some ideas.
It's going to tell the strength of what, Professor?
What's that?
It's going to tell you the strength of what?
Oh! Let me repeat that. This number, it's going to be a value, and it indicates the strength of the linear relation.
Okay.
We'll get a number. We're going to be able to look at these numbers and go, oh man, there appears to be maybe a strong or weak linear relation.
Okay.
So that's what it's measuring for us. This would be R equal to 1.0. Now, when you notice my dots are perfectly in a straight line,
Uh-huh.
and do you remember the word slope?
Yep.
You see it's rising from left to right. That's why it's a positive one. But do you ever get data that really does that in real life? Oh, come on, look at this is what we get, right? We get scatter plots. They're scattered all over the place. But if this really happened, we're talking, okay,
Why?
perfect, you know? Extremely strong linear relation, right? The best. And by the way, what if the dots went like this in a perfect straight line, and they came down like this?
-1?
You got it. So I want to put that. If you want to put -1.0 for emphasis, you can. Like 1.0 and -1.0. They're perfect. Perfectly straight. Those are the extremes. So now I'm going to do something like this. And because these are tight. I mean, these are grouped together very tightly and they're going up like this. So what would dots that maybe went like this, they were really close together. It's all going up in a straight line like that, it appears.
0.9.
Yeah, I'm going to put that down. And I'm just making this up. But they would give an R value of approximately 0.9. And we can interpret that as a strong linear relation. Cool? Hey, what if they were really tight?
Negative.
They did. But they were going down, they were really tight. Maybe R would be about -0.9.
So
Still strong though, right?
But
So this would be a strong linear relationship as well. The only thing is, positive versus what?
negative.
Negative. So if you want to, I'll go back in here, I said strong linear relation. In your notes, you can put the word positive before the word linear. But the word I'm going to put really big is linear. That's the most important word. Because that's what we're looking at. That's what we're examining. Is there possibly some linear relation between the two variables? If you want to say relationship, that's fine too. All right? That's what we're talking about when we're talking about correlation. Is there a linear relation? Right? Hey, and as I go through all this, everyone, will you remember one thing? Just because perhaps in the end we see, a correlation, correlation does not imply that you have causation. Will you remember that? Unfortunately, people do that in this world too often. They see like, I see a correlation. So that means this must cause this. I see a correlation between drinking coffee and this. Oh, then I guess drinking coffee is going to, cause cancer, right? You follow me. So,
It's a psychological thing too.
yeah, exactly.
Psychology.
Exactly. Very good. So correlation does not what? Necessarily imply causation. Right. But it's interesting when you see some type of correlation. All right. So 1.0, negative 1.0, 0.9, negative 0.9. I'm making all these images on the board. Everyone, the author did a great job with this. If you want to look at it, if you have your book right now, go to page 194. His pictures are going to be a lot better than mine. But I'll keep going with this. All right? I'll keep going with this. I want to do a couple more images for you. So if you're like, where would I see some representations of this? Oh, page 194 has this stuff. Okay? So the next one I'm going to do is moderate. So I think I'll go over here on what if you had dots that were, they're a little spread out, right? Like this.
Moderate relationship.
Yeah, but you can still see, oh my gosh, it looks like it is going up in a straight line, perhaps. They're just scattered about. Maybe this, you'll get a moderate linear relation. And